So mainly when you do algebra and stuff, you're talking about the real number system, but sometimes it comes up that you have an equation like x squared equals negative 1, where depending on where you are in a course or what course it is, you might say there's no answer. Um, but unfortunately, that's not always good enough. There are applications in real life where you actually have to find an answer. Um, so mathematicians found a way around it by coming up with complex numbers and imaginary units. So the imaginary unit, which we denote by I, oh, thought I had my pen ready. Guess I didn't. Let's see if I can write a little nicer. Sorry, that's pretty sloppy. Is the number whose square is negative 1. That is, I squared equals negative 1. And if you don't remember anything else from this lesson, if you remember that, you'll be in good shape. All right, so if we want to do an example like number 4, part A, square root of negative 9, we can find that now because we know what the square root of 9 is. It's 3. But since we're taking the square root of negative 9, we want to just tack an I on there. Part B, the square root of negative 64, would be 8i. And C, there's a negative on the outside, so we'll keep that. And on the inside would be 6i. So negative square root of negative 36 is negative 6i. D is square root of negative 63, which we want to write as a product of at least one number that has a perfect square. So negative 9 times 7, and we want the negative to go with the perfect square number because the square root of negative 9 we know is 3i. So it's 3i square root of 7. The square root of 7 will just stay there. All right. And part E. It's tempting to just go ahead and multiply the insides, but that doesn't work with imaginary numbers, or it doesn't work with negatives inside of a square root. Instead, just write down what it would be with the I. So we can't break down the square root of 11, so we would just write it as negative 1 times 11, and the square root of negative 3 would be negative 1 times 3. So remember, the square root of negative 1 is I. So we would get I square root of 11 times I square root of 3. I times I is I squared, and then square root of 11 times square root of 3 is square root of 33. I squared, remember, is negative 1. So negative 1 root 33, or just negative root 33. Same with F. Square root of 3 is fine, but we want to break down negative 27 as negative 9 times 3 because square root of negative 9 is 3i. And then we can multiply, now that what's under the square root for both sides is positive, we can go ahead and multiply that. We get 3i times square root of 9. Square root of 9 is 3, so that would be 3i times 3, which is 9i. All right, complex numbers are numbers of the form a plus bi, where a and b are real numbers. The real number a is called the real part of the number, a plus bi, and the real number b is called the imaginary part of a plus bi. And I is the imaginary unit, so I squared equals negative 1. When it's written in a plus bi form, it's called standard form. Bi is called the pure imaginary number. And then 8 through 11 are all the rules for adding, subtracting, and multiplying complex numbers. which really, you don't have to memorize that. Just remember that I squared equals negative 1. So, for example, 12a is the quantity 4 plus 5i times the quantity negative 8 plus 2i. Or sorry, it's not times, it's plus. All we do is we add the real parts, 4 and negative 8, which is negative 4, and then add the imaginary parts. 5i plus 2i is 7i. And if we subtract, same thing, negative 2. So this is the quantity negative 2 minus 4i, minus the quantity 6 minus 8i. Negative 2 minus 6 is negative 8. Negative 4i minus negative 8i, when you subtract a negative, you add, so that's going to be plus 4i. If you multiply 5i times 7i, that's 35i squared, and the I squared is negative 1, so this is negative 35. For D, 5i times the quantity 4 minus 7i, we want to distribute. So 5i times 4 is 20i. 5i times negative 7i is minus 35i squared. Remember that I squared is negative 1, so this is going to be 20i plus 35. E and F will FOIL. So E is the quantity 3 plus I times the quantity 2 plus 4i. So 3 times 2 is 6. 3 times 4i is 12i. I times 2 is 2i. And I times 4i is 4i squared. 12i and 2i is 14i. And then 4i squared would be minus 4, because that I squared is a negative 1. 6 minus 4 is 2, so you get 2 plus 14i. All right, F. The quantity 4 plus 3i times the quantity 3i minus 4. So 4 times 3i is 12i. 4 times negative 4 is negative 16. 3i times 3i would be 9i squared. 3i times negative 4 is negative 12i. So the 12i and the minus 12i cancel. 9i squared would be minus 9, so you get 16 minus 9, which is just negative 25. So the directions say write it in standard form, but sometimes you don't have both parts. So in C and in F, we only had the one part, and that's fine. G and H, we aren't going to do the problems that are there. We're going to do some problems that are going to be more like what's in your homework. So let me find those. G is going to be 14 over I plus 2. And H is going to be I to the 9th power times 1 plus I to the 8th power. All right, so G, it might not be clear what to do, but the idea is that we don't want any i's in the denominator. So we multiply the top and the bottom by the conjugate of the bottom, which just means you change the sign in the middle of the bottom and you multiply it by it. And you'll see what happens when we do that. So the top, I just distribute and get 14i minus 28, and that's done. The bottom, when I FOIL, I get I squared minus 2i plus 2i and minus 4. So when you multiply conjugates, those middle numbers are always going to cancel like that. I squared is negative 1, so you get negative 1 minus 4 is negative 5. So 14i minus 28 over negative 5. And then H, I to the 9th power times the quantity 1 plus I to the 8th. We can distribute, and we get I to the 9th plus I to the 17th. Remember, when you multiply the base, you have to add the exponents. So we know that I squared is negative 1. So if I broke down I to the 9th, to I squared times I squared. I squared times I squared times I. I squareds are all -1. So it'd be -1 times -1 times -1 times I. Well, -1 times -1 is 1, and that happens twice. So you see we just end up with I. Similarly, with I to the 17th, we would have I squared 8 times I. That would give you I to the 16th times I. And if I did I squared 8 times, since that's an even number, so you're taking a negative number to an even power, that's just going to be 1 and then times I. So you end up with I plus I, which is 2I. So you don't have to work this out every time. Just kind of keep in mind that if you have an even number of times that if the exponent is even on the I squared, then you're going to end up with just 1, which I have demonstrated here. I hope that makes sense. But make sure that you take some notes and write down your questions, and we'll go